Hey guys, I hope you guys are doing well. So first and foremost, big congratulations on getting paper 2 done yesterday. I'm hoping it went well for you. Obviously, I'm recording this before paper 2 has come out, so I'm hoping it went much better than paper 1. But yeah, we have to move on. We're on to stats and mechanics now. So this paper is 2 hours long. There's exactly 100 marks. It's a relatively straightforward paper. I've just tried to get as much as possible in there. There is a tricky question. The last question on stats, I think, is pretty tricky. Other than that, it's very standard stuff. You've got normal distribution, binomial. You've got standard deviation, mean. All of this good stuff in stats. And then mechanics, you've got obviously projectiles, moments, variable acceleration with vectors, SUVAT, all the good stuff, inclined planes, right? So all of the main standard stuff that you're gonna get. So between now and then, if you haven't done stats and mechanics in a long time, which I know some people do tend to neglect, just spend your time doing past papers such as these and other ones. So yeah, that's pretty much it. Timestamps will be in the description as always. Link for the paper will be in the comments and on my website. But let's get right into it, man. Last paper. Let's go. All right, so question 1 says, a group of 200 adults were asked whether they subscribe to Netflix, Disney Plus, or Prime Video. The replies showed that 27 subscribed only to Netflix, 34 subscribed only to Disney Plus, 39 subscribed only to Prime Video. 18 subscribed to Netflix and Prime Video, but not Disney Plus. 12 subscribed to Disney Plus and Prime Video, but not Netflix. 25 subscribed to Netflix and Disney Plus, but not Prime Video. 30 do not subscribe to Netflix, Disney Plus, or Prime Video. Part A says using this information, complete the Venn diagram on the next page. Well, I've got the Venn diagram right here. So we're just going to do it sentence by sentence. So first we'll put 27 subscribe only to Netflix. So that would mean I would have 27 on the outer part here. 34 subscribe only to Disney Plus. That means I'm going to put a 34 right here. And then 39 only to Prime Video. That means I'm going to put 39. Okay. And then it says 18 subscribe to Netflix, Prime Video, but not Disney Plus. So Netflix and Prime Video, but not Disney Plus. That would mean that that would have to go in the intersection part for only Netflix and Prime Video. 12 subscribe to Disney Plus and Prime Video, but not Netflix. So Disney Plus and Prime Video is right here. And that is 12. So that is going to be right here. And then 25 subscribe to Netflix and Disney Plus, but not Prime Video. 25 subscribe to Netflix and Disney Plus, but not Prime Video. That's going to be right here. Now, they've told us that 30 do not subscribe to any 3, right? So that means that's going to be on the outside. So that is pretty much it. And then now all we've got to do to calculate the intersection part would just be to add everything up and then take it from the total, which is 200. So let's do that and see what we get. So I'll do that right here. So what we got? We got 27 plus 18 plus 25 plus 34 plus 12 plus 39 plus 30. This is equal to 185. So 200 take away 185 is 15. So that means that 15 is going to go in the middle here. And that is the complete Venn diagram. So that's done. So now that I've got that, let me screenshot that and then use this to do parts B and C. So I'm going to just put this here. So put this here so we could use it as reference. Okay, so let me just move this down a bit. Got the Venn diagram on top. Now, what does it say? It says, let me just make sure you guys can see all of that clearly. Move this down a tad bit. Yeah, that's all good. So it says one of these adults was chosen at random. Part B says, find the probability that this adult subscribes to Netflix, Disney Plus, and Prime Video. Well, that's just going to be the very middle part, the intersection right here, which is going to be 15. All right, this is going to be 15 over 200, the total, which you can divide top and bottom by 5, which would be 3 over 40. Next part, double I. Find probably that they do not subscribe to Netflix. Well, if you don't subscribe to Netflix, then you're just going to literally be on the outer part, which is going to be this part here. Hold on, I'm doing green. This part right here. This is all of the people that don't subscribe to Netflix. So you just add up these and then divide it by 200, isn't it? So put that into calculator. What do I get for that? So calculator's there. That's going to be 39 plus 12 plus 34 plus 30 over 200, which is equal to 23 over 40. Okay, so this one here is going to be 23 over 40. And then you know what? I think because it's 2 marks, just put your workings out. So on the bottom, you have 200, and then you add up these. So 39 plus 12 plus 34 plus 30, just to show how we got that. Okay, so that's done. Part C, it says, given that this adult subscribes to Disney Plus, find the probability that this adult also subscribes to Prime Video. So Disney Plus is what we're looking at. So that means that immediately our denominator is going to be out of the people that are in Disney Plus. So let's do this. Let's just put how many people are in Disney Plus. Let me rub out these. And then Disney Plus is right there. It's this whole thing here. So it's going to be out of all of this. Okay. So it's going to be out of 25 plus 15. 25 plus 15 plus 34 plus 12. 34 plus 12. Finally, this adult also subscribes to Prime Video. So if you're in Prime Video in Disney Plus, it means that you're just here, isn't it? This is Prime Video while you're in Disney Plus. So this will be on the numerator. That's going to be 15 plus 12. Okay. So I know the top number is 27. I'm going to put the bottom number into the calculator, and that will give us the answer. So 25, I'll just do 27 over 25 plus 15 plus 34, because that's a 34, right? Because I know my 4s and 9s are the same. Yeah, 34 plus 12. 34 plus 12, this is equal to 27 over 86. Answer 27 over 86. And that's it. That will give you all of the marks for this question. All right, so question 2 says, Amara takes 12 free throws in basketball. The random variable x represents the number of successful free throws. The probability that Amara scores a free throw is 0.25. Part A says, using a suitable distribution for x, find probability of x equaling 4. So they haven't told us the distribution. There's pretty much two that you're going to do in stats, normal and binomial, right? Which one is it going to be? Well, look at the indicators. There are 12 free throws. That's a fixed number of trials. The number of trials is represented by x, which is successful. So successful failure. Probability of scoring a successful free throw is 0.25. So there's a fixed probability of success. These are all the indicators of a binomial distribution. So you should definitely remind yourself of the 4 bullet points for a binomial distribution. Okay. So we're going to use a binomial distribution. So what I'm going to get out my Casio Gangster 50. That's what I like to call it, because this calculator is a bad boy. I don't use this much, to be fair, though. I like to use the other one just for like day-to-day calculations. But when it comes to calculating distributions, probabilities, and stuff like that, this is the clear winner. So I'm going to use this. So what we're working with, we are working with, let's write what we're dealing with, actually. I just realized that's probably the best thing to do right here. So we're going to say x is binomially distributed, right? X is obviously the number of successful free throws. And the sample size is 12, n, and then p is 0.25, okay? So we're going to use that to work out what these probabilities are. So calculator, we're doing x equals, aren't we? So if I change that to an equals like that, and then I want 4, the num trial is n, which is 12, and the probability is a quarter, 0.25. This is going to equal 0.19 to 3 significant figures, which is what I'll give it to, because that's what the mark scheme does. What I'll give it to 3 significant figures, which is going to be 0.194, isn't it? So 0.194. Next one, probability of x is less than 4. Now remember, we're dealing with a discrete random variable. So probability of x being less than 4 is the same as probability of x being less than or equal to 3, isn't it? So we've got to work out what this one is. So just be careful of those. So doing that, I'm going to go back. I'm going to change this now to a less than or equal to, which will be that. And then I'm going to change it to a 3, aren't I? And then that will be it. And then that will give me 0.649 to 3 significant figures. So 0.649, right? That's part A. Part B says, Amara repeats this experiment each day for 70 days and records the number of days when x equals 4. Find the probability that there were at least 14 days when x equals 4. So this type of questionnaire, they love this, right? It's like a part B sometimes, where it's a binomial distribution problem in another binomial distribution, right? How can we know, right? Amara repeats this experiment each day for 70 days. So potentially this number of trials is 70 and records the number of days when x equals 4. Well, have we seen that before when x equals 4? It was in part A. They asked us to find the probability of x equaling 4 with this experiment, right? So there's a probability for x equaling 4. Question actually says find the probability that there were at least 14 days. At least, right? That is the language of a binomial distribution problem. So the first thing that you're going to do to get the first mark is I'm going to call the random variable d, right? So I'm going to say let d equal the number of days, right? number of days when x equals 4. Okay, that is going to be our new random variable, and we're going to say that this is going to be binomially distributed with a sample size of 70 because there's 70 days. And what was the probability of x equaling 4? It was 0.194. Okay, so I'm going to use this value to three significant figures just for consistency, right? And that's what they would do in the mark schemes. Okay, so what we need to work out is for this random variable d, the probability of d being greater than or equal to 14. Now, if you don't have the CG50, then all you've got to do is remember this is the same as 1 minus the probability of x being less than or equal to 13, right? So if you don't have this calculator, then just find the probability of x being less than or equal to 13, take it from 1. You get the same thing. But I'm going to use the CG50 because I've got at my disposal. So I'm going to click exit, and then I'm going to change this to that way. And then what am I doing? I want x to be 14. The num trial, the n now is changed to 70. And the probability of p is going to be 0.194, isn't it? So like that. And then that is going to equal 0.497 to three significant figures, right? So I'm going to write 0.497. Perfect. So that's done. That's part B. Part C, it says find an estimate for the total number of successful free throws Amara will score during these 70 days. There's only one mark. Well, this is just GCSE essentially, right? We're doing 70 days worth of free throws. Well, we know that one day, right? Remember, Amara takes 12 free throws in basketball. She's repeating this experiment where she's taking 12 free throws 70 times, right? Because there's 70 days. So what you could do is just this. You could say, well, one day is equal to 12 free throws. So how many free throws will she make in 70 days? Just times that by 70. Times that by 70. What does that give us? Calculator time. I'll use this one. 12 times. To be fair, you should have two calculators, in my opinion, in the exam. Let me know if you guys. I know some people do that, but yeah, that's my opinion. 840. And the question is asking us for the estimate, isn't it? Estimate the total number of successful free throws. Well, this is just GCSE, right? An estimate is the probability of the event happening times the number of trials. So I'm going to just say that the estimate is going to equal the probability of a successful free. I keep saying three. I'm struggling with this. Free throws times the number of trials, right? Which is 840. Well, the probability of a successful free throw was 25% or a quarter or 0.25 times by 840. That is just 840 divided by 4, which is 210. So that is the estimate. And that's it for parts A, B, and C. All right, so part D says, use a normal approximation to estimate the probability that Amara scores a total of more than 220 successful free throws during these 70 days for 4 marks. So I've just got what we have summarized in part C because we're going to need it. Normal approximation, you have to remember the rules. If I want to approximate a binomial distribution with a normal, then we say that the mean, mu, is going to be NP. And the standard deviation is going to be the square root of NP 1 minus P, okay? In our case, what is N, what is P? Well, N is how many free throws we're doing over 70 days, which is going to be 840. So N is equal to 840. And the probability of a successful free throw we know is 0.25, okay? So mu is NP, which is what we calculated in part C actually, which is going to be 210. N times P is 210. And then the standard deviation is going to be a square root of NP, which is 210, times by 1 minus P, which is 0.75. Okay, so put that in the calculator. Let's see what we get. I'll use this one. 210 square rooted 210 times 0.75. That is equal to 3 root 70 over 2, which is approximately 12.5, right? So I'm going to write 3 root 70 over 2 because it's the exact value, okay? So now, what are we going to do? Let's define our binomial distribution, the one that we're going to approximate. Let's call it S. Let's say S is the number of successful free throws over a 70-day period. right? And we're going to approximate this with a normal distribution, right? Let's call that T, yeah? So what we're going to say S is binomially distributed with N as, how many free throws are we doing? 840 over the 70 days. Probability of success is 0.25. And then let's say T is our approximated normal distribution. All right, approximate normal distribution. So we're going to say that this is going to be approximately T. I remember, generally speaking, we have mean for mu and then the variance, sigma squared. Okay, so the mean is mu, which is NP, which is 210. And then the variance is going to be that thing squared. If I square that, what would that be? I'll do answer squared, which is going to be 315 over 2, 157.5, right? So what's best to do? Does it actually matter? You know what I'm going to do? I'm going to do this. I'm going to just write 3 root 70 over 2 all squared, like that. Just so you know, this is the variance right here, because generally speaking, it's mu and then sigma squared, isn't it? So I'll do it like that just so it's super clear. Okay. Now we've got our normal approximation, our distribution that we're going to be using. Now the continuity correction. Okay. We want a probability Amara scores a total of 220 successful free throws, right? So if I was using this one, it would be P probability of S being greater than 220, but we need to approximate this with our normal approximation, okay? So what value am I going to use? What I like to do, and this is how I teach my students, just use bounds, error intervals from GCSE, right? If I'm at 220, what would be the lower and upper bound of this number, right? Well, take 5 and add take 0.5 and add 0.5. It would be 219.5 and it would be 220.5. Okay. Now the context of the question is saying that probability of S has to be greater than 220. Remember, discretely, that means it can't be 220. So what would be the first value that you'd pick for it not to be 220, right? Well, anything that doesn't round to it, the first number that doesn't round to it, which would be 220.5, would be the upper bound, wouldn't it? Okay. So therefore, we are going to say that this is going to be approximately the probability of T being greater than 220.5. Okay. And that's how you should always do these type of questions. It just depends on what they are. So for example, let's just say it was E dot G. Let's say it was a probability of S being greater or equal to 220. How was that different? Well, this is saying that it can be 220, right? From our bounds, what number at the lowest will give you 220? It would be the lower bound, right? You would choose this one now, wouldn't you? So you could say this is equal to the probability, or approximately, I should say, probability of T being greater than 219.5. Okay, so again, just get your boundaries, the upper lower bound, and just use the context of the question to help you. So let's go back to the actual question, which is that there. So let me write this now. Let me put this in a box on it so it's clear. This is just an example. That's just an example there. So now let's get the actual question, which is this. We need to work out what this is. So let me get what we need. So I'm going to copy this like that. I'm going to copy that there. And then I need the actual probability that we're working out. Because now it's just calculator work at this point. So doing that, we need to put this into our calculator and see what we get. So let's get the Casio Gangster back again. So normal distribution equals execute. And then what are we doing? We are doing greater than, aren't we? So I'm going to just go right there. And then I want 220.5. That. The standard deviation is 3 root 70 over 2, isn't it? So how can I put it in nicely? 3 shift root 70 divided by 2. We just put aside. Would that do it? Let me put a closed bracket here, just because I'm trying to make sure I'm not dividing the 2 in the root, right? Divided by 2, that will give me, yeah, perfect, because that's the number that we got, isn't it? And then the mean is 210. And that gives us 0.2013 to 3 significant figures. That will be 0.201. And that is it. That is how you go about doing these normal approximation questions. What I'm going to do, I'm going to put a text over there with a little graphic that you can use to help you memorize how to do the normal approximations right now. So just stop the video and then you can just screenshot it. But yeah, that's it. Done. All right, so question 3 says, as part of an investigation, Bobby collects a sample of 47 observations X. The results are shown in the following stem and leaf diagram where A is a constant. So with the stem and leaf diagram, you've got the key. 32 means 0.32, okay? Part A says find the range of these observations for 1 mark. So the range is the smallest, is the biggest takeaway, the smallest. So in that case, it's going to be this value at the end here, which is going to be 87, which is 0.87. So I'm going to write 0.87. And then we're going to take away the smallest value, which is the one at the beginning, which is going to be 21, which is 0.21. So that's going to equal 0.66, isn't it? That's done. Part B says find the value of the median of these observations. So there's 47 is an odd number. So the median is going to be n plus 1 over 2. So 48 over 2, the halfway point, which is going to be 24. So we're looking for the 24th position. And what we have in brackets here are the amount of data for each row, right? So there's 5 data points here, there's 10, etc. We want the 24th. So 5, 10 is 15. Add 11 is 26. So it's going to be in this row here. This is the 26th one. This is the 25th. This must be the 24th. Okay. So the median is 48. The median is 0.48. So I'm going to write 0.48 there. Now, it says for part C, given that the interquartile range of these observations is 0.31, find the value of A. So interquartile range, right? IQR. This is literally equal to the upper quartile, Q3, minus the lower quartile, Q1. So what do we have? They've given us the interquartile range, which is 0.31. And this is going to equal the upper quartile, right? So whatever that is, let's write Q3, minus the lower quartile, which we can figure out, okay? Because when let's look at the upper quartile, it's going to be the 36th position, right? Which is going to be this value here, which is what we're looking for. The lower quartile we can find, right? So what do we have? The lower quartile is going to be 1/4 of the data. N plus 1 is 48. Divide that by 4 is going to be 12. So we're looking for the 12th position for the lower quartile. This is 10. This is 15 altogether. So this is the 15th position. This is the 14th. This is the 13th. This is the 12th position right here. That is 3.5. This is 0.35. So therefore, the lower quartile is 0.35. Okay? And then from here, we can easily figure out what the upper quartile is. So what I'll do, let me just zoom out a little bit. I'll just do it, I'll do it right here. So that means that 0.31 plus 0.35 is equal to Q3. So the upper quartile is equal to 0.66, okay? Which would mean that that value of A has to be 6, isn't it? Quite clearly, yeah? So if I was using that diagram, the key would mean that I'd have a 0.6A. And then obviously it's not an equation in terms of the manual sense, but you're just solving that. A is going to quite clearly going to equal 6. Okay. So I'm going to just put A is equal to 6 like that. And that's it for parts A, B, and C. All right. So part D says, Bobby calculates the statistics from these observations. The sum of X is equal to 23.72. The sum of X squared is equal to 13.4228. Part D says, show that the standard deviation of these observations is 0.17623 significant figures for 2 marks. So I've just got the first line, right? Just so we know the number of observations that we're dealing with, okay? So remember, to calculate standard deviation, there's a formula. So all right, sigma, this is equal to the mean of the squares minus the square of the mean, right? Square root. So right, so generally speaking, no, it won't let me do that, will it? Let me just do it nicely. So I'll do that, and then I'll do this. Yeah, it's better. All right, so it's going to be equal to the mean of the squares. So the sum of X squared over n minus the square of the mean. So sum of X over n all squared. All you got to do is just literally plug this in and see what you get. So that's going to be sum of X squared is 13.4228 divided by the observations, which is 47. Take away the square of the mean. So the mean is going to be 23.72 divided by 47 all squared. So we're going to literally just put this into the calculator and see what we get. Let me move this here so we can see the calculation. So square root 13.4228 over 47 minus 23.72. 0.72 over 47 all squared. And this gives us 0.17575, so right there. 0.17575 blah blah blah, which is 0.176 to three significant figures. And that's it for part D. Now part E, it says Bobby now collects 18 more observations, Y, from the same investigation. Part E says using all 65 observations, the sample mean is 0.502 and the sample standard deviation is 0.204. Part I says show that the sum of Y is equal to 8.91. So we've got 18 more observations. Firstly, it was 47 that were X. We've got 18 more, which is Y. Okay. Now they ask us to show that the sum of Y is 8.91. They've given us this information here about all 65, right? So what we could say is that the mean of these 65 observations, right? Mean of all 65, right? Surely that will equal the sum of all of the 47 observations, which is going to be the sum of X. And then I'll add on those 18 observations for Y, so the sum of Y. And then this is going to be divided by the total, 47 plus 18 is 65. And this is going to equal the mean, which they told us is 0.502, okay? But remember, we know what the sum of X is already. They gave it to us. I think it was 23.72, yeah. So what I can do is put that in. So I'm going to write the sum of X is equal to 23.72. So therefore, we're going to have 23.72 plus the sum of Y, over 65 is equal to 0.502, okay? I don't like the way I wrote in sum here, to be honest. So then from here, this is just literally a linear equation. Times by 65, take away 23.72. So I can say from here, the sum of Y is going to equal 0.502 times by that 65, and then you will take away the 23.72, wouldn't you? So what would that give us? Let's see. So do it here. 0.5, make sure, yeah. 0.502 times by 65 minus 23.72 is equal to 8.91. Exactly what they wanted, isn't it? 8.91, because it was a show that, yeah, perfect. So that's done. Now double like to show your work and calculate the sum of Y squared. So it's going to be the same thing in terms of the fact that they've given us the standard deviation for this 65 observations. So we're going to just do the exact same thing, isn't it? So as I do it here, all right, SD, remember, it's the mean, it's the mean of the squares minus the square of the mean. So for the 65 observations, right, I'm going to say sigma is going to equal the mean of the squares. So that would have to be the sum of the X squared values plus the sum of the Y squared values, right, over all 65 observations, right, minus the square of the mean, right, which to be fair is going to be the sum of X plus the sum of Y over 65, which we actually know, which is the mean was 0.502, isn't it? So technically I don't even need to put that. I can just do this 0.502 all squared because we know it, okay? And they told us that this is equal to 0.204, okay? So this is where I'm at, 0.204. And then what do I have? 0.204. And oh yeah, we have the sum of X squares, don't we? That was what was it? 13.4228. 13.4228. So I write this down. So now it's just a matter of just putting everything in and then just solving. Okay. So doing that and then doing that. That's going to be 13.4228 plus the sum of Y squared over 65 minus 0.502 all squared is equal to 0.204. So how do we get the sum of Y squared from there? So first square both sides. So if I square both sides, then everything, the square root will go. So I'm going to just copy that and write out again because it'll be faster for me to do that. So I'll just paste it there and then bring this in. Oh, we didn't get the denominator, which is fine. I'll just put it in. So I'll have that there, like that, and then this is going to equal, I have to square the right hand side as well, don't I? So yeah, 0.204 all squared. And then now I would add that on, times by 65, take that away. So I'll just do it in bits just so it's clear. So 13.4228 plus the sum of y squared over 65 is going to equal 0.204 squared plus 0.502 squared. And then you times by 65, wouldn't you? And then take away the 13.4228. So therefore we can say the sum of y squared is going to equal times by the 65. So 65 times by all of that plus 0.502 squared. And then I would have to take away the 13.4228. And whatever I get here is going to be the answer. So putting that into the calculator, what does that give me? 65, 0.204 squared plus 0.502 all squared, close bracket, minus 13.4228. So let's just do that. Let me just double check I'm putting that in correctly. Looks all good to me. So therefore, I get to three significant figures, it's going to be 5.66. All right, to 3 SF. And that's it. This is the question finished. Okay, so question 4 says, a company claims that 70% of customers who sign up for a free trial continue to a paid subscription. A new marketing campaign is introduced. At the end of the campaign, a random sample of 25 customers who signed up for a free trial was selected, and it was found that 21 of them continue to a paid subscription. Investigate whether there is evidence that the proportion of customers who continue to a paid subscription has increased. You should state your hypotheses clearly and use a 5% level of significance. And this is a 4-marker. Standard hypothesis test question. Let's look at it closer. We've got a claim of 70%. That's a probability of 0.7. We've got an observed, we've got a sample size of 25. We've got an observation of 21. This is going to be a binomial hypothesis test. So first things first, let's write down our null and alternative hypotheses. So here's what we know to be true, which is going to be 70%, which is 0.7. And then we are investigating whether there's evidence that the proportion of customers who continue to pay subscription has increased, so greater than. So I'm going to say P is greater than 0.7. It's a one-tailed test. Okay. Now we assume the null hypothesis. So what would the binomial distribution be? It will be the sample size here. There's 25 customers who they found at the end of the campaign, right? Or they used the sample size 25, like that. And then the probability we assume is 0.7. Now, with hypothesis test, with binomial hypothesis testing, with normal hypothesis testing, there's always going to be an observed value, right? So look, it says a random sample of 25 customers who signed up for a true trial selected, and it was found that, or in other words, observed that 21 of them continue to a paid subscription. So the observed value in this case is going to be 21. And what you always want to do is observe. You want to find the probability of observing this value under the null hypothesis. Okay. So what you're going to do is this. You're going to find the probability of X being, now you always use the direction of your alternative hypothesis, which is greater than. So the observed is going to be greater than or equal to 21, right? You need to calculate this probability. This is the test statistic, and then compare it to your level of significance. Okay. So I'm going to get my calculator. I'm going to use my Casio Gangster and figure out what that probability would be. So I'm going to click execute, and then we want binomial. I'm going to change X to 21, and it's still greater than, which is fine. The num chart is going to be 25, and the probability is going to be 0.7, isn't it? So putting that in, what do we get? We get 0.904, right? So 0.09, isn't it? Yeah, 0.0904. And then we have to compare this to our significance level, which is 5%. So what I like to do is this, 0.05. Is this bigger? Yes, it is, right? So now you're here, you need to make an interpretation. What happens when your test statistic, the value that you get, the probability of observing values is greater than your significance level? it means you accept H0 and reject H1. Okay. So what I like to do is this, I say, write this, accept H0, reject H1. And then now, once I know exactly what I'm accepting, what I'm rejecting, you now need to write a statement. Okay. You need to write something in context, a conclusion. So what you're going to do is say, there is insufficient evidence at 5% level of significance that, and what was the context again? We had a company claiming that 70% of customers sign up for a free trial continue to pay subscription, right? And we'll investigate whether there is evidence of proportion of customers who continue to pay subscription has increased. So literally just copy that, right? So there is insufficient evidence at the 5% level of significance that, and then literally copy this, literally copy it word for word there, right? That the proportion of customers who continue to a paid subscription forgive me for the handwriting, it's this graphics tablet has increased. And that is it. That will give you the 4 marks. It's the same thing each time with these hypothesis test question. Done. So question 5 says, the lifetimes of a brand of light bulb are normally distributed with a mean of 1200 hours and a standard deviation of 150 hours. Part A says, find the probability that a randomly selected light bulb lasts between 1000 and 1300 hours for 1 mark. This is just standard probability calculation. So standard calculator work, where is my pen? There it is. So part A, let me write the distribution. It's normally distributed the lifetimes of these light bulbs with a mean of 1200 and a variance of 150 squared. Okay. So we want the probability that a randomly light bulb lasts between 1300. So we're looking for the probability of X being between 1000 and 1300. So that is just very easy calculator work. So let's put in the calculator and see if we get something going normal. And then I'm going to do this one. And then the lower bound is going to be 1000. The upper bound is going to be 1300. The standard deviation is 150. And the mean is 1200. And this is equal to 0.656 to 3 significant figures, isn't it? So 0.656 to 3 SF. Now part B, what does part B say? It says, given that 10% of light bulbs last longer than K hours, part B says, find the value of K to the nearest hour for 2 marks. Okay, so they've given us a percentage, in other words, a probability, and this apparently lasts longer than K hours. That's a value on the distribution, right? So what I like to do with these questions is draw the distribution, okay? We just draw a curve. You don't have to, but I like to. It just helps me visualize the questions better. So I've got this here. The mean is 1200. And then apparently there's a value for K such that the lifetime hours is more than 10%, right? Given that 10% of light bulbs. So this is going to be 0.1 here. Like that, 10% here, and then this is going to be 0.9. Okay, now let me write this here again. This is the distribution for 1200 and then 150 all squared. Now we want the value of K, which happens to be a value on our curve. How do you go about doing this? You're looking for a value given a certain probability. What should be ringing in your mind? Inverse normal, right? So what I like to do is this. I'm now going to draw a second bell curve. And this is going to be my standard normal, right? So Z is going to be normally distributed with a mean of 0, standard deviation of 1, okay? It's going to be 0 here. And remember, this is your key when you're doing these questions, right? What we're saying here, or what you're doing with a standard normal is remembering that this is like your basis, and then every distribution can be coded with this normal distribution, the standard normal. So there's a value of k on this one, or let me say z actually, which would correspond to k. So I'm going to say that on this side there's 0.1 and this side is 0.9, right? We want to figure out what value of z that corresponds to. Why? Because there is a formula. Remember, the coding formula is, all right, coding formula. This is equal to z is equal to x minus mu over sigma. Now, in our case, we don't know what z is yet, but our value of x is going to be k. And we know what the mean is. It's 12,000. No, sorry, it's 1200 divided by the standard deviation, which is 150. Okay, we need to figure out what that value of z is, right? And then we could use that to solve for k. So how do we do that? We just use the inverse normal. So I'm going to get my calculator out, get this one. We'll go to, how do I do it again? I'm going to menu. Is it not? No, I know it is. It's not in here. I remember now. It's here, I believe. And then you can go distribution, and then you're going to go to, is it this one? Oh no, how do I do this again? Distribution, normal, yeah, INVN, yes, inverse normal. So let's look at what we're dealing with. This is our graph here. We want the area to the right to be 0.1, don't we? And the standard deviation is 1, the mean is 0. And then this gives us 1.28155, blah, blah, blah. So therefore, I'm going to say z is equal to 1.2855, blah, 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 from inverse normal. So INVN, right? So what I'm going to do, I'm going to just round that to 5 decimal places, should be fine. 1.28155, that should be fine. So then now I'm going to plug that in and then solve for k. So I'm going to say then that that becomes 1.2855 is equal to k minus 1200 over 150. So therefore k would equal to, we'd have to times by that 150, 1.2855 times 150, then we add on 1200. So it's going to be 1.2855 times by 150 times by 150, and then we have to add on that 1200. Okay, so k is going to be whatever this is equal to. So I'm going to put this into the calculator, I'll do it into this one. That's going to be 1.2855 times 150 plus 1200. This is equal to 1,392. 1,392.825, which is approximately, remember, to the nearest hour, that's going to be 1,393 hours. So that is our answer for K. And that's it. All right, so part C says a different manufacturer claims that their light bulbs have a mean lifetime of less than 1,200 hours, right? A random sample of 64 light bulbs from this manufacturer is taken and the mean lifetime is found to be 1,165 hours. Part C says carry out a suitable test to assess the manufacturer's claim. You should state your hypotheses clearly, use a 5% level of significance. Okay, so normal hypothesis testing, again, very, very similar structure. You put your null, put your alternative, get your observed value, etc. So firstly, let's write out our null and alternative hypothesis. So where's my point? So we've got H naught, which is going to be mu, the mean what we know to be true, which is 1,200 hours. So mu is going to equal 1,200. And then this manufacturer claims that the mean light bulbs have a mean lifetime which is less than that. So H1 is going to be less than 1,200. Okay. Now, what do we do now? It says a random sample of 64 light bulbs from this manufacturer is taken. Okay. Now, remember, you always have your population and your sample. So I'm going to write the normal distribution for the population, right? So X is the lifetime in hours for this different manufacturer of the different manufacturers' light bulbs. Manufacturers' light bulbs. Just move this to the side. Put light bulbs, okay? bulbs. Okay. So as I said before, you guys, please, this pen is not allowing me to write properly. Anyways, as I said before, population and sample. So the normal distribution for the population would be X is normally distributed with a mean of what we assume to be 1200, like that. And then the standard deviation is 150, isn't it? Okay. Like that. So it'd be sigma squared, right? Now, the population, sorry, the sample, right? Let me write population here. The sample you put a hat over, right? And then it's very, very similar. It's the same thing. However, you always have to divide your variance by your sample size, which in this case are 64 laptops. I said laptops, light bulbs. 64 light bulbs, okay? So we're going to be using this. Now that we've done this, remember, just like binomial hypothesis testing, there's always going to be observed value. It says that a random sample of 64 light bulbs from this manufacturer is taken, and the mean lifetime is found to be 1,165 hours. So this is going to be, remember, found to be is the same as observed, right? The observed value is 1165. So I like to write this. Observed is equal to 1165. So we want to find the probability of observing this value. What is this equal to under this distribution here? So look at the direction. Remember, it's a one-tailed test. So we have to do the probability of X hat being less than the observed, which is 1165. So we're going to put this in to the calculator and see what we get and then compare it to our significance level. So do it into this one here. I'm going to go to menu. I'm going to go to distribution, and then I'm going to go to normal, and then I'm going to what we're doing, it's not joint, it's just one side, so that, and then the value of X is 1165. The standard deviation, right? Well, let's just put this here. So remember, this is the variance, sigma squared. That's what I always do so I don't make a mistake. It's 150 squared divided by 64. The variance is the square root of that. So to square root that, you would square root the top. So the square would go 150. And then you would square root the bottom. 64 square root is 8. Okay? So that is going to be the standard deviation. That's what you're going to be. That's what you're going to put into your calculator. So 150 divided by 8. Like that. And then that gives us that there. And then the mean is 1,200. Put that in, and we get this there. So we get 0. Was that 0, isn't it? Yeah. 0. Hold on. One more time. Yeah. 309. We compare this to 5%. This is less than, right? So what is it? What do you do when the probability is less than your significance level? It means you reject H0 and you accept H1. Okay? So now what do you do? What is your conclusion? Analysis, right? So now you're going to say there is sufficient evidence. And then what was the claim? The manufacturers claim that their light bulbs have a mean lifetime of less than 1,200 hours. Would you read it again? Yeah. Different manufacturers claim that their light bulbs have a mean lifetime of less than 1,200 hours. There's sufficient evidence or to support, this is better. There's sufficient evidence to support the manufacturer's claim that the mean lifetime is less than 1,200 hours. Lifetime of light bulbs is less than 1,200 hours. You know, now that I think of it, yeah, why would they claim that it would be less than? Wouldn't you want more hours for your light bulbs? Yeah, I didn't think about that. But the maths is all the same. So yeah, that's it. Done. All right, so question 6 says, for a certain value of the constant p, the random variable x has the probability distribution given in the table. So we've got x from 1 to 4. We've got the probabilities p is 6p, p squared and a half. two independent values, x1 and x2 of x are found. Determine the probability of x1 plus x2 equaling 6, given that x2 is greater than x1 for 8 marks. So it's 8 marks. There's a lot to do here. But first things first, even if you don't know what to do, right, you have a probability distribution. The probabilities are in terms of p. You know that all probabilities sum to 1. So the first thing that you can do is form an equation in terms of p to figure out what p is and actually complete the probability distribution. Okay, because you're going to need p to figure out the question. So let's go ahead and do that. So we've got p plus a 6p plus p squared plus a half is equal to 1. That's 7 6. This is a 1p, isn't it? That's 7 6p plus p squared. If I move that 1 over, that would be minus a half, isn't it? And then that will equal 0. If I times everything by 6, I can get a nice quadratic. So if I times by 6 here, then I'm going to have 7p plus 6p squared minus 3 is equal to 0. So therefore, I've got 6p squared plus 7p minus 3 is equal to 0. Then I can just solve for p, can't I, in my quadratic solver. So I'm going to go to menu, equation, go to number 3. Yeah, 6, 7 minus 3 is going to be a third. So p is going to equal a third, or p is going to equal minus 3 over 2. Now, obviously, we know that probabilities have to be between 0 and 1. So therefore, p can't be negative. So we can immediately disregard this solution and say that this is our winner here. So p is equal to third. And then now we can actually complete the table, can't we? So if I get that table, I'm just going to get this table. And then I'm just going to put this here. Like that. So if I put that there and then grab it and then move this inside like that. And then what do we have here? So we now know that p is a third, so we can complete this. Okay, so let me color these in white. So let me do this. Put these in white like that, like that, like that. Okay, so if I put that in, this was p, so p is a third. Can't remember what 2 was. 2 was a 6th p. So a third times a 6th is 1 over 18. And then 3 was p squared. So a third squared is 1 over 9. Okay, so we've got our complete probability distribution now. Let's actually go to the question now. Let's look at this. So this looks a bit daunting at first, but you just got to break it down. Okay, so now, oops, trying to get this there. All right, so first things first, when I look at this, whoops, I'm trying to grab it. First thing that I notice is that this is a conditional probability. It's something given at something else. So for me, what comes to mind is the conditional probability formula, which you should know off by heart. Probability of A given that B happens is equal to the intersection of A and B divided by the probability of B happening. Okay, so what I like to do is this. Okay, fine. If I use that, that tells me that our event A is going to be x1 plus x2 equals 6. Let me put in a colon actually. Okay. So the event A is x1 plus x2 equals 6, and then B is x2 being greater than x1. Okay. Now, what are x1 and x2? These are the independent trials. Okay. So let's read the question again. Two independent values of x1 and x2 are found. Okay. They're independent. So probability of x1 happening has no effect on x2 happening. So when you do them together, you multiply. So we need to figure out what these are, okay? So what I'm going to do first is I'm going to actually put this into the formula. So it's going to be the probability of A, which is x1, plus x2 happening, equaling 6. It's going to equal, or not equal, sorry, I'm doing the right-hand side. So this one, let me just make sure so it's clear. So this right here is this, okay? And then now I'm going to compute the right-hand side, okay? So therefore, it's going to be equal to the probability of x1 plus x2 equaling 6 intersection the event B. So x2 is greater than x1. It's going to be out of the probability of x2 being greater than x1, okay? So we need to compute these and see what we get, and that will be our answer. So let's put this on the next page. So put that there. And then what I'm going to do actually, let me actually write the left-hand side so it's complete. So that would be the probability of x1 plus x2 equaling 6, given that x2 is greater than x1. Yeah, that is perfect. Okay, so how do we go about doing this? Well, firstly, I think what we should do is compute the denominator first, because there's probably going to be more for that one. Okay, so x2 has to be greater than x1. Well, let's go back to our table and look at it and see what we can do. So if I'm going to copy this actually. Let me copy this like that. Okay, so there's only 4 values, 1 to 4. So it's not going to be too many that we're going to be looking at. So let's have a look and see. So we want the second value of x to be greater than the first value. Well, there's only a certain amount of times that can happen. So let's just say, for example, I start off, let's say I'm going to do it in brackets in terms of pairings. Okay, let's say that my first value is 1. If the second value has to be greater than 1, then it can either be 3. That's one possible scenario, or it can be 1 to 4, and it could be what? Sorry, I forgot the 2. So 1, 2. Just do it like this. So 1, 2, 1, 3, 1, 4. That could work, or it could be, if I start with 2, then it could be 2, 3, 2, 4. Or if I start with 3, then it could be 3, 4. And that is it. These are the only ways that the second probability, the second value, is greater than the first. Okay. So then now we need to compute this. Okay. So the probability of where's my pen gone? The probability of x2 being greater than x1 is going to be equal to the probability of you getting your x1 to be 1, and then your second one 2, and then you've got this. So this is what we're gonna compute. I'm gonna write or here like that. 1, 4, or probability of 2, 3. So let's close that bracket, get rid of that bracket there. Or 2, 4. Or the last one, probability of 3, 4. Now, how do we compute these probabilities? They're easy. You're just going to times them together, right? So the first one, probability of 1 and 2, that's going to be probability of 1 is 1/3. And then I need to get 2. So 1 over 18, like that. Remember, or is a plus. So it's now going to be probability of 1/3 times by 1 over 9. Plus 1/3 times by 1/2. Okay. And then the next one is now the 2's. Okay. So plus, and the probability of 2 is 1 over 18 times by 1 over 9. That's 3. Like that. And then, so let me just make sure I've done that correctly. 1 over 18, 1 over 18, 1 over 9. That's fine. And then 1 over 18 and a half. 1 over 18 and a half. And then the last one is going to be plus the probability of 3 and 4, which is going to be 1 over 9 times by 1 over 2. Like that. Okay. So again, let me just, what would be the best thing to do here, just to make sure you guys can know which ones I'm dealing with. Yeah, I'll just do it like this. I'll just number it. Right. So this is 1, 2, 3, 4, 5, 6. And this is it. 1, 2, 3, 4, 5, 6. These are the corresponding probabilities for each of the scenarios where x2 is greater than x1. So we just need to compute these. I'm just thinking, what's the best thing to do? Should I just quickly tidy it up and then do it? These numbers are okay. You know, I'm going to just put this all into my calculator. I think that'll be the best thing to do. So if I do that, let's put this in. So 1 over 3 times 1 over 18. 1 over 18 plus 1 over 3 times by 1 over 9. Plus, what's the next one? 1/3 times a half. To be fair, I know these, but I'm just going to do it just so it's complete and let's just, so there's no mistakes, times a half. Like that. Plus 1 over 18 times 1 over 9. Close bracket. Plus 1 over 18 times a half. What does this black thing mean? Oh, I can't do any more. All right, so then that means I'll just do the first 4, which is equal to 37 over 162. So it's going to be these right here. This is going to be 37 over 162. And then plus then the last two, and I add them together. So 1 over 18 times a half plus, and then what was the last one? 1 over 9 times 1 over 2. 1/2. This is equal to 1 over 12. So be that and that. And then what do you get when you add these together? This will be the probability. So 37 over 162 plus a half. Or a top, sorry. This is going to equal 101 over 324. So we've calculated the probability of x2 being greater than x1. This is very crucial. Just about to say, probability of x2 being greater than x1 is equal to 101 over 324. So we've computed the denominator, haven't we? Right here, we've computed the denominator. We know exactly what this is. This is 101 over 324. Now we need to compute the numerator, which states that the probability of x1 plus x2 equaling 6, but it's also x2 greater than x1 at the same time, okay? So let's compute x1 and x2 being added equaling 6. So when does that happen? Let's do that here. So let me write this here. x1 plus x2 equals 6. How can that happen if the first trial, if the first event and the second event add to 6, right? Well, it goes from 1 to 4. What numbers can you add in those 4 that will make 6? That's the first thing that you want to do. First thing that I can think of is if I start with 1, I can't get to 6. 2, I can. 2 and 4, right? Then the next one I can do is 3 and 3, right? The next one I can do is 4 and then 2, right? These are the possible pairings whereby when you add the first event to the second event, you get 6. However, though, remember, there is a condition. This has to also satisfy x2 being greater than x1, right? So although this is the possible pairings, you have to say, but x2 must be greater than x1. So therefore, which of these pairs satisfy that? The second trial is bigger than the first. It's only the first option, right? 4 is the last trial, the second trial. 2 is the first, so that's satisfied. 3 and 3, those are the same. x2 will equal x1 in that case. That's not the condition. 4 and 2, that would mean that x1 is greater than x2, which can't work. So the only possible answer is 2 and 4. It's the only solution, right? So then now we compute that, right? So therefore we can say that the probability of x1 plus x2 equaling 6, as well as intersecting with x2 being greater than x1, this is equal to the probability of 2 and 4, okay? And then what is that equal to? That's just probability of 2 times the probability of 4. Probability of 2 is 1 over 18. Probability of 4, I think we probably have done it, to be fair. Yeah, we've done it here. It's this one. This one right here. It's the second to last one. 1 over 18 times 1/2. Like that. This is equal to 1 over 36. So now we've got everything we need. We've got the numerator and we've got the denominator. So what I'm going to do, I'll put this on the next page here. Let me just copy this, put this on the next page here. We can actually work this out. So therefore, the answer to this one is going to equal, let me get my pen. This is equal to the numerator, which we've just figured out to be 1 over 36. 1 over 36, all divided by the probability of x2 being greater than x1, which we worked out to be 101 over 324. 101 over 324. So what is this equal to? Just put this into the calculator and see what you get. So what I'm going to do, just to make it easier, is I've got the denominator stored. So I'm going to write answer. That will make it easier. And then I'm going to put 1 over 36 at the top. Or you know what? For completeness in this walkthrough, let me actually put it in. Why not? 101 over 324. Like that. The answer is 900. So I said 900. 9 over 101. Square please, box it. Come on. Let me try again. That is the answer. That is the answer. and that will give you all 8 marks. Brilliant, brilliant. Let me know what you think of this question. I actually got this question from an OCR paper and I just adapted it. What I'll do is I'll put the original question in the description. It's very, very similar. I just adapted the first condition very, very subtly. So yeah, and that's it. That is stats done. All right. So question 7 says a motorbike is moving with constant acceleration along a straight horizontal road. The motorbike passes a point P and 10 seconds later passes a point Q. The speed of the motorbike as it passes Q is 28 meters per second. Given that PQ is 220 meters, find the acceleration of the motorbike for part A. So let's do it sentence by sentence. So motorbike passes a point P 10 seconds later. So T equals 10. So let's put T equals 10 just from there. What else do we know? The speed of the motorbike as it passes Q is 28. So we've got P to Q. So let's just put P here. And let's just put a line like that. And let's say this is Q. We know that the speed here is 28. So P to Q, that must mean it's the final velocity. V equals 28. The distance of P to Q, this right here is S. This has to be 220. And we are looking for the acceleration. So all you got to do is get your letters that you know. So we know T equals 10. We know that V is 28. And we know that S is 220. And we are looking for A. So ask yourself this question: what formula connects these four variables together? In SUVAT, it is S is equal to VT minus a half AT squared, isn't it? So I'm going to use that one. So what does that mean? I'm going to have S equals 220, V is 28, T is 10, minus a half, and then A is what we're looking for, and then T squared is 10 squared, so like that. So what do I have here? I have 220 is equal to 280, and then minus a half times 10 squared. 10 squared is 100, half of that is 50, so it's going to be minus 58. So therefore, if I move the minus 58 to the left, bring the 220 to the right, I'm going to have 58 is equal to 280 minus 220. So that would mean that 58 is going to equal 60, isn't it? So therefore, that would mean that A is going to equal 60 over 50, which is 6 over 5, which I know is 1.2. So therefore, the acceleration of the motorbike is 1.2 meters per second per second. So that's part A. Part B, it says find the distance traveled by the motorbike during the 5th second after passing P for 4 marks. So you got to be careful. What does it mean when it says 5th second? That doesn't just mean plug in T equals 5. It means the interval between the 4th and 5th second. That is what you want to calculate. So what I'm going to do, I'm going to just draw a little diagram to visualize this. So let's put P here, that, and then let's say we've got Q, for example, like that. Now, what do we know? We know that this is V equals 28. This is 10 seconds in. And what we're saying here is 4 seconds in, what is that distance there? So let's just put, let's call it S4, right? This is when T is equal to 4. What is that distance? And then what is the distance when T equals 5? Like that. We'll see that's T equals 10, so it'll be further to left, but you get the idea. Essentially, what we want to calculate is this distance here, how far the motorbike is after P, 4 seconds in. And then we want to calculate how far it is after 5 seconds there, right? And then the actual answer, the distance traveled in that 5th second, the 4th and 5th second, is going to be this distance in blue. So you find the distance in yellow, find the distance in green, take them away, get the blue distance, which is what you're looking for. So how do we go about doing that? Well, we've got this model here. What we can do is we can figure out what U is, isn't it? Right? We can figure out the initial velocity of this motorbike, and then we can use the S equals ut plus alpha t squared. So let's do that. We've got U is equal to, or we're looking for it. We know that A is equal to 1.2. We know that the distance between P and Q was 220, and the time it took was 10 seconds. So I've got that there. And then we put everything in. I've got V equals 28. So to be fair, I want A, I want U, UA. I could just use V equals U plus AT to be fair. That might be the easiest formula. V equals U plus AT. I'm going to use it to figure out what U must be. So I've got 28 is equal to U plus A, which is 1.2, times by T, which is 10. So therefore, I'm going to have 28 is equal to U plus 12. So therefore, u is going to equal 28 minus 12, which is 16. Okay, so now I've got the initial velocity of this motorbike. Now I can use the s equals ut plus a half at squared formula to figure out the distances for given times. Okay, so I'm going to say u equals 16. So then now, let's do it on this page here. I'm going to use s equals ut plus a half at squared. And what do I know? I know that u is equal to 16. And I know that a is equal to 1.2. Okay, so generally speaking, the distance traveled is going to be 16t plus a half, and then a, which is 1.2 t squared. Got the t here. So therefore, we could say it's going to be s is equal to 16t plus 0.6 t squared. And then I can use this to figure out the distances. So what I'm going to do, let me copy this diagram. Okay, so copy that, put this on the next page here. Oops, sorry. Need to grab the whole thing, don't I? Whoops, let me try again. So grab this whole thing and put this here. So I want the yellow distance, right, which is S4. So I'm going to plug in 4 into my formula. So S4 is going to equal 16 times by 4 plus 0.6 4 squared. Like that. That's going to equal, calculator, 16 times by 4 plus 0.6 times by 4 squared. And that's going to be 73.6. Okay. So this distance here in yellow is 73.6 meters. This is where the motorbike is after 4 seconds. Now we're going to work out what S5 is. So 16 times by 5 plus 0.6 times by 5 squared. So what do we get? So just changing those to 5 now. We're going to get 95. Okay. So this is 95. And then this green distance, right, is 95 meters. So therefore the distance in blue, which is going to be S5, take away S4, that distance traveled in the 5th second is going to be 95 minus 73.6, which is equal to 95 minus 73.6 is equal to 21.4. So that distance right here is 21.4 meters. So answer is 21.4 meters. And that's it. All right, so question 8 says, at time t equals 0, a particle P is at the fixed point O. At time t seconds, where t is greater than 0, P has position vector r meters relative to O, where r is equal to 3t plus 2 minus 2 root t plus 1i plus t squared minus 6tj. Part A says, find the speed of P at the instant when P is moving in the direction of the vector I for 5 marks. So first, a couple of things, right? We are given the position vector, right? So you can think of that as displacement. And they've asked about speed, right? Well, we know that speed is the magnitude of velocity, right? So firstly, for us to find out what the speed is, we need the velocity vector. So what I like to do is this. Remember, obviously, when we're not dealing with vectors, it's, we write S, and then we write V, and then we write A, right? This is displacement. All right, displacement for short. This is velocity, and then this is acceleration. Okay, to go down, you differentiate. So I'm just write dy dx, ddx, and then to go up, you integrate. Okay, so we are currently at the displacement, the position vector r. So we need the velocity. So we have to differentiate this vector to get the velocity vector. So that's the first thing I'm going to do first. So I'll do it in components. So I'm going to just write I for the I component. Now this is 3t plus 2 minus 2 root t plus 1. So what I'm going to do is I'm going to write that as t plus 1 to the half. This is a chain rule problem, isn't it? So if I differentiate that, that will give me, let me write d dt, right? If I differentiate that, that will be a 3. The 2 will disappear. And then what have I got? I've got minus 2. Chain will bring the half to the front. T plus 1, take 1 away from the power. And then times by the inside derivative. So therefore, this is just going to tidy up and be 3 minus the 2.5 will cancel. It will just be t plus 1 to the minus a half, isn't it? And that would be the I component, right? So that's going to be the I component for the velocity vector. And then for J, this is easy. This is just t squared minus 6t. So if I differentiate that, d dt, then that will give me 2t minus 6. Okay, so therefore the velocity vector v is going to be the I component, which is going to be this expression right here. 3 minus t plus 1 to the minus a half I plus the j component, which is this one right here. 2t minus 6 j. Okay, so we've got the velocity vector. Now, the next part of the question, it says, find the speed of p at the instant when p is moving in the direction of the vector I. So when you see that phrase, moving in the direction, that is describing your velocity, okay? Moving in the direction. Now, it's moving in the direction of the vector I. What is I? I is a horizontal component. It's going horizontally, yeah? So remember, positive, by the way. So I is literally equal to this. It's going completely horizontal, right? This is what the vector I looks like, unit vector for I. It's going completely horizontal. If the particle, does it say particle? Doesn't actually matter, yeah. If the particle P is moving horizontally, what does that tell you about the J component? It must be 0, right? So I'm going to write moving in I direction implies the J component is 0, okay? So we need to figure out the time where that occurs. So all we've got to do now is remember, this is our velocity vector right here. This is our I component. This is our J component, right? If it's moving horizontally, this thing right here must be 0. So we're going to set that equal to 0 and figure out what value of t that happens for. So 2t minus 6 is equal to 0. That tells me that 2t is equal to 6. And that tells me that t is equal to 3. So it happens after 3 seconds. So now to find them, what did it ask us for? The speed of p. So we now know what the time is. We plug it into our velocity vector and take the magnitude. So I'll do this. So v is going to equal, and it will be 3 minus, and then it will be 3 plus 1 to the minus a half I. And then obviously if I put t equals 3 into there, that will just be 0, isn't it? Right? So that will just be 0j. Obviously we reversed it and found it. So we know that that's 0. So I'm going to just put this in now and see what I get. So putting that in, I'll do it here so you can see me as well. So 3 minus 3 plus 1 to the minus a half. This is equal to 5/2, right? Or 2.5. So I'm going to say that v, the velocity vector, is going to equal just 2.5 I. So therefore the speed, which is the magnitude of v, is going to equal just the Pythagoras of that component, 2.5 squared, like that, right? Which is just going to cancel. That's just going to be 2.5, isn't it? Right? So the answer is going to be for the speed, is going to be 2.5 meters per second. And that is it. Done. All right, so part B says, find the magnitude of the acceleration of P when t equals 0.25 for 4 marks. So I've got everything we need. I've just got what R is and the velocity vector. Why? Because it says magnitude of the acceleration. So remember, we started with the position vector R. We differentiated, gone down to velocity. Now that asks about acceleration, we need to differentiate again. So what I've got to do is differentiate this velocity vector to get the acceleration, okay? So doing that, what will that be? So I'm going to have A, which is what we want, is going to be dv by dt, isn't it? So that's going to be, if I differentiate that, the 3 will disappear. This is another chain rule problem. Bring the minus a half to the front to join that minus will be a positive a half. And there'll be t plus 1. And then take 1 away, it'll be minus 3/2. And then times by the inside derivative, t plus 1 differentiates to 1. It'll be like that. And then I, and then plus the derivative of 2t minus 6 for j is just going to be 2j. So tidying this up, I'm going to have 1/2 t plus 1 to the minus 3/2. And then this is going to be I at that plus 2j. And this is going to be our acceleration vector. So they want it when t equals 0.25. So I'm going to sub in t equals 0.25 into that and see what I get. So the calculator is giving it to me in third form. So I'm going to do it by hand. So I'm going to do, which you don't have to, by the way. You just got to keep it consistent. So 1/2 and then 0.25 plus 1. This is minus 3/2. Like that. And then what's that? This is 1/2 and then 1.25 to the minus 3/2. 1.25 is 5/4, isn't it? So that'll be 5/4 to the minus 3/2. Index laws, that will be, that minus will make it flip. So 4/5 to the 3 over 2. And then cube both of them and then root. So that would be 1/2 times by 64 over 125. And then now we've got to root it. Okay. So therefore, we're going to have this is going to equal 1/2 times by the square root of 64 is 8. Square root of 125, I'm going to write as root 125. And then now what I can do from here is that 8.5 can just make a 4 over root 125. So now the acceleration vector when t equals 0.25 is going to be 4 over root 125 I plus 2j. And then now what do I want? I want the magnitude of the acceleration of p. So all I'm going to do now is I'm going to put this in. So it's going to be magnitude of that is going to equal the square root of the squares of these components. So 4 over root 125 squared plus 2 squared. So putting that into the calculator, what does that give us? So let's do that there. So I'm just going to do root, and then that's going to be 4 over root 125, like that, squared plus 2 squared. And that is going to give us 2 times root 64, blah, blah, blah. Let's do this like that. This is going to equal 2 root 645 over 25, I believe. Let me check again. Yes, which approximately is, to 3 significant figures, will be 2.03, right? So 2.03 meters per second. And that's it. Done. All right, so part C says, show that P never returns to O for 2 marks. So I've just got the position vector of R because we're going to need it. Well, if you're at O, that's the origin, right? It means you haven't gone anywhere. So I'm going to say at O, right? It must mean that both the I and J components are 0. So we could say that R is going to equal 0i plus 0j. What you can do as well is read it. It says at time t equals 0, a particle is at the fixed origin, fixed point O. So plug in t equals 0 into there. Both of them, just to convince yourself, you're going to get 0 and 0, okay? So let's just assume it did return to O, right? What would that actually mean? Let me write this here. So I'm going to say if P did return to O, then there would be some value of t that would satisfy both of these components being 0. So I'm going to say if P did return to O, then for some t, all right, some value of t, right? Then what would we have? We'd have 3t plus 2 minus 2 root t plus 1 is equal to 0. And then this one, t squared minus 6t has to equal 0. There's going to be some value of t that satisfies both of these equations being 0. Well, let's try and find it. Well, this equation at the top is a bit complicated. There's roots and stuff. Makes sense to look at the bottom one because it's a quadratic. It's going to be at most 2 solutions. So let's solve the bottom one. I'm going to have t bracket t minus 6 is equal to 0. That means either t is equal to 0 or t is equal to 6. These are the only possible values for t. These are only possible values of t that would allow the position vector to be 0, okay? So all I've got to do now is plug in either one. Well, remember, we know that this when t equals 0, it's at the origin, right? So we've got to plug in t equals 6 and see whether or not we get 0 in that in the I component, okay? So let's plug in t equals 6. T equals 6 into I. This will give us 3 lots of 6 plus 2 minus 2 root, and then 6, isn't it? 6 plus 1. That is not 0. That's 18 plus 2 minus 2 root 7. That is equal to 20 minus 2 root 7. This is not 0 last time I checked, right? So therefore, what we can say is that no further values of t. Values of t. Whoops. Further values of t give r equals 0. Right? So therefore, p never returns to O. And that is it. That will give you the 2 marks. All right, so question 9 says a particle P of mass m is held in equilibrium on a fixed rough inclined plane by a light and extensible string. The plane is inclined at an angle alpha to the horizontal, where alpha is equal to 45 degrees. The string is inclined to the plane at an angle alpha as shown in figure 1. The string lies in a vertical plane that contains a line with greatest slope of the inclined plane. When the tension in the string is 0.75 mg, P is on the point of moving up the plane. Part A says find an expression for the magnitude of the frictional force acting on P. Give me an answer in terms of mg and alpha, and this is a 3 marker. So I've just got it summarized here. It's going to be easier for me to annotate. So the first thing that you want to do is get your force diagram going. So we've got a particle of mass m, so that means that the weight is going to be mg. I hate when it does that. So down like that. It's going to be mg. We're going to have a reaction force here. And then obviously, this has tension, right? But they told us the tension is 0.75 mg. So I'm going to put that there. And then now, what else do we have? Well, remember, it's on the point of moving up the plane. Friction opposes motion. So the friction would be acting in the opposite direction. It's going to be on its way down because it will be opposing it. So let me draw friction like that. Let's just do an F here. And then now what I want to do is resolve any forces that aren't acting parallel or perpendicular to the plane, which is going to be this weight of mg. So remember, we're going to just drop a perpendicular line here like that. This angle is always alpha. This is next to it. So this right here is going to be mg cosine that's adjacent. This one is opposite the angle. It's going to be mg sine alpha. So I just use that. I just label that mg sine alpha. So we've got those two components of that weight mg, and then this one can be resolved too. If I drop a perpendicular like that, this is a right angle. Then I hate when it does that, man. Goodness me. Then this is opposite. This is gonna be 0.75 mg sine alpha, and then this one right here is going to be 0.75 mg cos alpha. Okay. So I think that's done in terms of labeling everything and resolving everything. They said that we need to find F. So we just need to resolve parallel to the plane, don't we? So what I like to do is highlight any forces acting parallel, which is going to obviously be this one, the frictional force, this parallel component of this weight, and this parallel component of the tension. Okay. So going downwards is the F and the mg sine alpha. So I put it on the same side. So it's an equilibrium. So all of the parallel forces acting one way will be equal to one's acting in the other. So F plus mg sine alpha will equal the 0.75 mg cos alpha. So to get F, it's just a matter of moving that to the right. So F is just going to equal 0.75 mg cos alpha minus mg sine alpha. And then if you want, you can take out the mg. This is fine, to be fair. Just give you the 3 marks, but you can take out the mg, and then you have 0.75 cos alpha minus sine alpha. And that's it. That will give you the 3 marks for part A. All right, so part B says the coefficient of friction between P and the plane is 1/2. Part B says show that tan alpha is equal to 2/5 for 6 marks. Okay, so 6 marks, it may seem a bit daunting, but it's literally just a bit of algebra here. So the first thing that you should notice is that they've told you the coefficient of friction. So immediately for me, when I see that, I think of F equals mu R, right? Now, coefficient of friction, which we call mu, is 1/2. So therefore, from there, we can say that F is equal to 1/2 R. I'm going to be looking at this equation, and hopefully I can get it from here. So for me, is it a matter of just plugging in F and R? Probably, right? We know what F is from part A, so we can use that. Are we able to get an equation for R in terms of cosine and sines? Absolutely, by just resolving. So we just plug those in. We're going to get in terms of sine and cosine, yada, 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 sine because it's tan. You know the rest. So let me get our expression for F, which was that there. Mg times 0.75 cos alpha minus sine alpha. So I'm going to say F is equal to Mg 0.75 cos alpha minus sine alpha. Okay. And then let's get R by resolving perpendicular to the plane. So if I do that, then I can see here, I've actually already done it, I've highlighted it. So the forces going up are these two, right? R and 0.75 mg sine alpha. And then we've got this mg cos alpha going down. So therefore, I can say that I've got r plus the 0.75 mg sine alpha. And this is going to equal the force going down, which is mg cos alpha. Okay? And then from there, we can figure out what r is quite easily. Mg cos alpha minus 0.75 mg sine alpha. Okay? So that is r. So now we can plug this into f equals a half r, and then obviously use the algebra to see what we get. So plugging it into f equals a half r right here, f equals a half r, that would mean that I'm going to have mg and then 0.75 cos alpha minus sine alpha is equal to 1/2 of r. 1/2 of r, which is that thing there. So mg cos alpha minus, I need to put a bracket here, minus 0.75 mg sine alpha. Okay? And to be fair, probably be better if I factorize out that mg because it can cancel, isn't it? So what I'm going to do, I'm going to write this like this. 1/2. If I take out the mg like that, then it will leave me with cos alpha minus 0.75 sine alpha, wouldn't it? Like that. And then I'll have this on the left-hand side. Copy that. Put that in like that. So that means it will become like this, wouldn't it? And then from here, we can see quite clearly that the mg's can cancel, can't they? So I can cancel that mg, just dividing both sides by mg. And then from here, I'm going to have 0.75 cos alpha minus sine alpha is equal to 1/2 of cos alpha minus 0.75 sine alpha. I'm going to times both sides by 2 to get rid of that half. So I'm going to have, if I times this by 2, then that will become 1.5 cos alpha, wouldn't it? That'll be minus 2 sine alpha is equal to just cos alpha minus 0.75 sine alpha. Now remember what we're trying to show. Always have what you're trying to show at hand. Tan alpha is equal to 2/5, right? Let me write this. Let me write this here. I'll write it in red and box it. So tan alpha is equal to 2/5. That's what we're trying to show. Okay? And this is where we're at so far. So what you'd want to do here is essentially get your sines and cosines on the same side. So I'm going to move this minus 2 sine alpha here to the right, and I'm going to move this to the left, right? So at least they both are positive. So that would be 1.5 cos alpha minus cos alpha, right, is equal to, that's going to be a positive 2. So I put it at the front, 2 sine alpha minus 0.75 sine alpha. So what do I have? I've got 1.5 minus 1. That's a 1 right there. That's going to be 0.5 cos alpha. And then 2 take away 0.75 is 1.25 sine alpha. Now we know that sine over cosine is tan. So let's divide by the cosine and then divide by the 1.25. So cross divide. Is that a thing? I've never heard of that, but you guys get what I mean. So I'm going to do 0.5 over 1.25 is equal to sine alpha over cos alpha. And then what's that? Well, sine over cosine is tan. And this is 0.5 over 1.25. If I times top and bottom by 4, 0.5 times 4 is 2. 1.25, sorry, times 4 is 5. Like that. So therefore, tan alpha is indeed equal to 2/5 as required. And that will give you the 6 marks for part B. Perfect. So part C says, the string breaks. Determine whether P remains at rest. You must justify your reasoning. So I've just got the diagram here. The string is broken. And I've got tan alpha is equal to 2/5 because we're going to need it. So the string is broken. What would the force diagram look like now? Well, we'd still have a reaction force, obviously. We still have a reaction force R. We still have this vertical weight going downwards, which is going to be mg. And obviously, we're going to have the components, aren't we? So let me just do this like that. Let me just do it like this, to be honest. Like that. Why does it keep doing this? Anyways, you guys get the picture. I have that, and then this angle is always alpha. This is mg adjacent cos alpha, and then this is mg sine alpha, isn't it? Okay. Now, if it doesn't remain at rest, it would be going down, right? But it depends on the friction. So let me put the friction in. Remember, when the string was attached, it was being pulled up, right? The puller pulling up, friction was acting down the slope. If it's gonna move and not remain at rest, then friction would act in the opposite direction. It would be moving up the slope. Okay. So to answer the question whether or not this particle remains at rest, this particle P, we just need to determine whether or not the friction is big enough and large enough to stop it from moving. How do we do that? Well, we need to determine how it will move. How will this particle move? It will move via this parallel component of the weight, okay? So I need to compare that force, mg sine alpha, with the friction. If mg sine alpha is smaller than the friction, then the friction is large enough to oppose it. If it is bigger, then the friction is powerless and it will move down. So we just need to compare those two forces, okay? Now, we've got tan alpha is equal to 2/5, which is fantastic because now we can figure out our trigonometric ratios, okay? So let me get a right angle triangle going. And then we're going to do SOHCAHTOA from GCSE. SOHCAHTOA, the opposite is 2. The hypotenuse, sorry, the opposite is 2, the adjacent is 5. So therefore the hypotenuse is going to be the square root of 2 squared plus 5 squared, isn't it? So let's put it into the calculator. Actually, square root of 2 squared plus 5 squared, that's the square root of 4 plus 25, that's root 29. Okay, so I can put that in. So I've got my three sides, so therefore I can figure out what sine alpha is and what cos alpha is. Sine alpha will equal the opposite over the hypotenuse, so 2 over root 29. And then cos alpha will equal the adjacent 5 over the hypotenuse, 5 over root 29. Okay? So now, what do I do? Well, I can compute the parallel component of that weight, right? It's just going to be mg sine alpha. So it's going to be, I'll say, mg sine alpha is going to equal mg times by 2 over root 29, which is going to be 2 over root 29 mg. I'll just write it like that. Now, I need to figure out the frictional force. Now, remember, F is equal to mu r, isn't it? Okay? So I'm going to say that F is equal to, remember the coefficient of friction, by the way, was a half from part B, or from the beginning of the question anyway. So I'm going to say F is equal to a half R. Now, the reaction force is going to change because that string is broken. Okay, so we need to compute that reaction force again. So the reaction force is going to be this, and it's going to be like that. Okay, so if I do that, and I can say that resolving perpendicular to the plane is going to give me R is going to equal mg cos alpha, and then obviously cos alpha is 5 over root 29. So I'm going to have R is equal to mg and then 5 over root 29. And so therefore I can write this as 5 over root 29 mg. So therefore the frictional force, which is a half of that, we can write this as F is equal to 1/2 of R, 5 over root 29 mg. And then if I put this into the calculator, it'll probably rationalize it for me, wouldn't it? So let's do that, see what we get. 1/2 times 5 over root 29. That gives me 5 root 29 over 58. So the frictional force is 5 root 29 over 58 mg. Okay? Now we need to compare this with the parallel component of the weight. Is it bigger than this? If it is, then it will move. If it's not, then it won't move because the friction will stop it. Okay? So what was the parallel component of the weight? It was this thing right here. So if I compare that, right, I'm going to write, let me just write weight, parallel component, parallel comp, excuse my handwriting, right? That is going to be 2 over root 29 mg. And then comparing those, what I can do is, if I rationalize that, what would that give me? Just to make it easier to look at, 2 over root 29 is equal to 2 root 29 over 29. So this right here, I write this as 2 root 29 over 29, okay? mg. Now, these have the different denominators. Make them the same denominator. We might as well double this. Times top and bottom by 2. That will give me 4 root 29 over 58 mg. And then now there's no denying which is greater, right? Because they have the same denominator. So just compare the numerators. 5 root 29, 4 root 29. The friction is greater than the parallel component of the weight, as we can see quite clearly. So therefore, I'm going to write it here. Therefore, friction is greater than parallel component of the weight. So therefore, P, what was the question saying? Whether it remains, it does remain at rest, right? Doesn't move. Remains at rest. And that's it. There was a similar question. I can't remember what year it was in one of the papers, but it was a similar question like this where they asked you about whether a particle remains at rest and you had to compare the friction and the parallel component. It's the same thing here. So that's it. That's question 9 finished. All right, so question 10 says the fixed points A and C lie on horizontal ground. The point B is vertically above A with AB equaling 10 meters. At time t equals 0, a particle P is projected from B with velocity xi plus yj meters per second, where x and y are positive. Particle P moves freely under gravity and hits the ground at C. At the instant before P hits the ground, the velocity of P is 3i minus 15j meters per second, as shown in figure 2. Find the value of x and the value of y for 4 marks for part A. So I've just got it summarized down here. I think it's just gonna be easier for me to annotate. So first we need to find x and y, which are the components of the initial speed. Now we're dealing with projectile motion. Remember, the acceleration happens vertically only. There's no horizontal acceleration, so the speed is constant. So if I've got initial speed right here, which is xi plus yj, and I've got a final speed right here, 3i minus 15j. If the final horizontal component of the speed is 3, right, so must the initial, right? So we can just deduce that x must equal 3 because the speed is constant horizontally. So that's the first part. We've got x is 3. Now we need to figure out what y is. Now we're going to deal vertically, okay? So I think I'm going to do it here just because it'll be nice because you can see the question as well. So if I deal vertically upwards, right, then we'll treat upwards as positive. That means that the acceleration will be minus g. The initial speed, which I'm going to call u and then subscript y, is going to be y. The final speed, right? Always treat these projectiles as like coordinates, right? Essentially, we know that the final speed right here is 3i minus 15j. Vertically, that means that the final speed is minus 15 for y, right? So I'm going to write minus 15 here. And what else do I know? At this point C, in relation to the point B where we started from, we are 10 meters below it. We've treated upwards as positive. We're going to say S is equal to minus 10. Okay? We've got S is equal to minus 10. And then now, it's a matter of, we've got A, we've got U, we've got V, we've got S. What SUVAT formula connects all 4 of those together? It's V squared is equal to U squared plus 2AS. Right? So let's plug in everything that we know. So I'm going to have minus 15 all squared is equal to u squared, which is going to be y squared, what we're looking for, plus 2 lots of a, which is minus g, and then 10, which is minus 10. So what do I have here? I've got minus 50 squared. I know that's 225. And then this is equal to y squared. I've got 2 negatives, so I'm going to have a positive. 2 times 10 is 20. I've got 20g. So therefore, 225 minus 20g is equal to y squared. So therefore, y squared is going to equal, so not y squared, y, because that's what I want now, y is going to equal the square root of 225 minus 20g, okay? So just put that into the calculator, what do you get? Square root of 225 minus 20 times 9.8. This is equal to root 29. Right, so that is the value of y approximately. Just give it to 3 significant figures. If they don't ask, this is going to be 5.39. 5.39. And that is it for part A. That will give you the 4 marks. X equals 3 and y equals 5.39. Let me write this here just so we have it. X equals 3 and y equals 5.39. All right, perfect. Part B. It says find the greatest height above the ground reached by P for 2 marks. So Very careful, by the way, with these type of questions. It says the greatest height above the ground. So immediately, whatever the greatest height would be, which is going to be right here, you have to add 10 to your final answer, okay? Sometimes that can trip people up, right? So what I want to do is use the projectile to figure out what the vertical height would be here. And we know what the velocity, the vertical velocity would be at that point. It would be 0, isn't it? Right, I'm going to write Vy here is going to equal 0. We now know the initial component of the vertical speed. So it's going to be Uy. We're going to call it root 29 because we have it. I'm going to use root 29 because it's just exact. And then we know that A is going to equal minus G. And we're looking for the height. So what I'm going to do, I'm going to write part B here. Right, max height. Max height is when we've got A equals minus G. We know that the vertical component of the velocity must be 0. We know that the initial component right now, we found it is root 29. And we're looking for the max height, which is S. Yeah? What is that? So we've got A, V, U, and S. We can use V squared equals U squared plus 2AS again. So using that, that's going to be V squared is going to be 0 squared. So 0 squared is going to equal root 29 squared, which is just going to be 29, isn't it? But I write it like that. 29 all squared plus 2 lots of minus G and an S, okay? So where are we at now? Let's just tidy this up. So what do we have? We've got 0 is equal to 29 minus 2GS. So therefore, 2GS is going to equal 29. So therefore, I'll do it right here. Can you guys see that? I think you guys should be able to see that. That should be fun. That means that S is going to equal 29 divided by the 2G. So that height is going to be 29 over 2G. 29 over 2 times 9.8 is going to equal 1.479, blah, blah, blah. So therefore, what should I do? I'll do it right here. I'll do it right here. Therefore, the max height, right, is going to be equal to the initial height above the ground, which is 10 meters, plus the maximum height of this projectile, right, from the point B. So this point right here is going to be 1 point something, 1 point whatever it was, 1.479 right there, okay? So it's going to be 10 plus 1.479 blah, 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 which is going to be 11.479 blah, blah, blah. So just put in answer plus 10. This is going to equal 11.479. And then to 3 significant figures, we'll do it to 3 significant figures. It's going to be 11.5 meters. And that would be the answer for parts A and part B. All right, so part C says, find the distance AC for 4 marks. Okay, so immediately, what is AC? AC is quite clearly a horizontal distance, right? So for me, that brings me to horizontal motion, right? We're dealing with projectiles. We have a vertical component of speed, horizontal component of speed, okay? Now, because I'm dealing with a horizontal distance, well, what is the horizontal component of speed? We know that it's constant and it's 3, okay? So this distance AC, remember, the distance horizontally with a projectile is literally just the speed times the time. So I'm going to say that this distance here is equal to the speed times the time, okay? So in our case, I'm going to say that the distance AC is going to equal the speed, which we know is a constant 3 times t, right? Generally speaking, right? The question is now, what is t? How can we find out what t is? What's the distance A to C? Do we know anything about this point C? Absolutely. We know the speed at what it's traveling at, vertically and horizontally, and we have the start point from B. So what we can do is we can use SUVAT vertically to figure out the time at which the particle gets to C, and then we can use that and plug it into the distance formula, which is going to be 3t in this case. Okay, so we just need to figure out what t is. So how can we do that? Let's do that. Let me zoom out a bit. I'm not sure if my big head's in the way. I'll do it here. So if I treat upwards as positive, what do we know again? We know obviously that A is going to equal minus G. We know the initial vertical component of speed, which is why I wrote it there. I even forgot I wrote that. But yeah, 3i plus root 29j. So therefore, uy, the initial component of the vertical speed, is going to be root 29. And the final one, vy, at c is minus 15. And then what is t? Well, all we have to do is ask ourselves what SUVAT formula connects A, U, V, and T is V equals U plus AT. V equals U plus AT. Plug in all that we know. So I'm going to have minus 15 is equal to root 29. And then plus A, which is minus G. T, right? So I have minus 15 is equal to root 29 minus GT. So therefore, I can say that GT, if I move it to the left, and I move that minus 15 to the right, it'll be root 29 plus 15. So therefore, the time is going to be root 29 plus 15 all divided by G. That is what the time is going to be when the particle reaches C. Okay? So putting that in my calculator, I'm going to have root 29 plus 15 over G, which is 9.8. And this equals 2.08 approximately. So I'm going to say this is equal to 2.08 approximately. So therefore, the distance AC is going to equal 3 times that number. 2.08 blah, blah, blah. What is that going to be? Putting that in. I'm just going to literally just do 3 times answer. 3 times answer. This gives me 6.24 for 3 significant figures. So, all right, 6.24 meters for 3 SF. And that's it. That will give you the 4 marks for part C. And that is question 10 finished. All right, so question 11 says a uniform beam AB of weight 5W and length 12A rests with end A on rough horizontal ground. A package of weight W is attached to the beam at B. The beam rests in equilibrium on a smooth horizontal peg at C with AC equal to 9A as shown in figure 3. The beam is inclined at an angle theta to the ground where tan theta is equal to 5/12. The beam is modeled as a rod that lies in a vertical plane perpendicular to the peg. The package is modeled as a particle. The normal reaction to the beam and the peg at C has, read that again, the normal reaction between the beam and the peg at C has magnitude kW. Using the model, part A says show that K is equal to 56/13 for 4 marks. So this type of question here, we've got a beam typically towards the end of the paper, probably going to be a moments question. Okay, so first things first, let's get everything going in terms of our force diagram. We've got a uniform beam, which the weight is 5W, that acts down the center. I'm going to put a 5W bang in the middle about here approximately. So this is 5W here. What else do we have? We have a rough horizontal ground. Okay, so we've got a beam which is making contact with this ground. So there's going to be a reaction, a vertical reaction here. We'll call this RA. And also there's going to be friction. It's not moving. If it were to move, it would slide down to the left. So the friction, when it's not moving, is going to act towards the right. It's the same with these questions all the time. So I'm going to put a frictional force to the right going there. And then what else do I have? It says a package of weight W is attached to the beam at B. B is right there. There's a package of weight W. That's going to be right there. I'll put a W right there. And then what else does it say? It says something about a reaction. Yeah, the normal reaction between the beam and the peg at C has magnitude kW. So this is the reaction right here. So I'll put reaction like this. I'm going to call this kW. Okay. So now we're pretty much done, I believe, in terms of the force diagrams. Is there anything I've missed out? I do not believe so. So now we need to show that K is equal to 56/13. So moments question, this comes up every year. You're going to have a moments question. We've got 2 forces acting at A. What you always want to do when you're doing these questions, take moments about the point where there's the most forces acting because you can disregard them. So you're going to take moments about A, get an equation in terms of K's and W's, etc. Show that K equals 56/13. So what I'm going to do is I'm going to say, well, other than, let me just write here. I'll do it here. I'll do some of it here and I'll do some of it underneath. We'll take moments about A. Remember, it's an equilibrium. So that means that the anti-clockwise moments, whatever they are going to equal the clockwise moments. And what's the definition of a moment? It's just the force times the perpendicular distance to that point. So when I look at this here, the most obvious one I can see is this kW, right? This is a normal, so it's perpendicular to this beam. This is going that way. That is anti-clockwise. And this distance from the peg C to A is AC, which is 9A, right? So this distance right here is 9A, okay? Let me just make sure you guys can see everything I'm doing, by the way. So that means that the moment of the kW force is going to be the force times the perpendicular distance. So it's going to be kW times by 9A, okay? That is the anti-clockwise moment. Now I've got these ones. This one W right here. and this one 5W right here, right? Now what I do is this when I'm doing these types of questions, I'm gonna draw the beam like this, and then this force here, 5W is like this, and I'm gonna just extend it down like that. Let me know if you guys do it like this as well. So this is the point A, like that. This is the line here, this angle is theta. Okay, what I do is this, I drop a perpendicular, and then I say to myself, this is the direction of the force. If it was to be moments about A, it would swing that way, wouldn't it? That is a clockwise moment, and that perpendicular distance is whatever this thing is right here. Okay, now the weight acts down the center, doesn't it? Right, so therefore this is going to be 6A. So what I do is I do this. This might be a bit long, this is how I always do it. I'm gonna draw I'm gonna draw another right angle triangle. This is just gonna represent the distance. So this is going to be theta, like that. This is going to be 6A because it acts down the middle. What is this distance right here? Well, this is going to be adjacent. This is going to be 6A cos theta, isn't it? And this will be 6A sine theta, but it's the cos theta one I'm looking for. This distance right here is 6A cos theta, okay? So therefore, I can say that the moment for the 5W force is clockwise, and the moment, I'll say moment for 5W is going to be equal to 5W the force times by the perpendicular distance, and this is going clockwise. Okay, so therefore on the right hand side it would be 5W times 6A cos theta. So I'll write that there, 5W times 6A cos theta. Okay, now we still have this other force W, isn't it? I'm going to just draw this like this, like that, and then yeah, that weight is W at B. And then again, it's the exact same thing, right? This is a perpendicular. It's going to swing that way, but it's from A all the way to B, which is the length of the beam, isn't it? Right? 12A. So again, if I was to draw another triangle, it's the same thing. You could probably see it, but I'm going to just do it anyway. I'll draw another triangle like this. This is going to represent the distance now. This is A. This is B. This whole length is the whole length of the beam. This is 12A. So therefore, this is going to be 12A cos theta. And this would be 12A sine theta. Right? But we're just interested in the cos. So therefore, the moment, so, all right, therefore the moment for the W weight is going to be the weight itself, which is W, the force, times by the perpendicular distance, which is 12A cos theta. Okay? 12A cos theta. And then that would go there, right? It's clockwise too. So we plus 12 W, sorry, not 12W, will be W, because that's the weight, times by 12A cos theta. And this is going to be our equation. Let me just double check that. W times 12A cos theta. Yeah, fantastic. So this is going to be our equation, and we're going to need to show that K equals whatever they ask us to do. So I'm going to now put this on the page with the writing is. So I think I can do this here actually. So I'm here now. Let me just move this here. This is where we're at. Now, we know that tan theta is 5/12, so I can find out what the trigonometric ratios are. So let's do that. I'm just making sure you guys can see everything. Yeah, that should be fine. So therefore, I'm going to say that tan theta is equal to 5 divided by 12. If I draw a right angle triangle for that, there's lots of right angle triangles with these type of questions, isn't it? So that's theta. Opposite over adjacent, this is the opposite, that's the adjacent. This would be 13, right? Using Pythagoras. So therefore, cos theta, which is what I'm interested in, is going to be equal to the adjacent, which is 12, over the hypotenuse, which is 13. So then I can put that in there, can't I? So if I tally up this equation now, 9kWA, it's going to be 9kWA is equal to 5W times 6A is going to be 30WA cos theta plus 12WA cos theta. And then we know what cos theta is, but before that we can cancel a few bits and bobs. So WA, 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 we can cancel those. So therefore we can say goodbye, goodbye, goodbye. Then I have 9k is equal to, I've got 30 cos theta plus 12 cos theta. And that's going to be 42 cos theta. So 9k is going to equal 42 cos theta. And then I can plug in cos theta now. So therefore 9k is going to equal 42 times by 12 over 13, which is equal to, let's put this in, 42 times by 12 over 13. This is equal to 504 over 13. So I'm going to have 9k is equal to 504 over 13. And then that means I'm going to divide by 9 now. So k, divide by 9, divide by 9. If I do that, answer divided by 9, 56 over 13. As required. And that is it. That is how you go about doing these questions. Let me know if this is how you guys do it in the comments as well. But yeah, that is part A done. All right, so part B says the coefficient of friction between A and the ground is mu. Given that the beam is resting in limiting equilibrium, part B says find the value of mu for 6 marks. So immediately a couple of things, right? Find the value of mu. Mu is a letter. How do you find letters in maths? Algebra. Solve equations. What equation comes to mind when I think of mu? Immediately, F is equal to mu R. Okay, so that's the first thing that I'm going to write down. I've got a couple of things here from part B, which is what we're going to need. But F equals mu R. Now, how do we know it's F equals mu R? It says something quite clear. It is in limiting equilibrium. So you know F is at X maximum and F max is mu R. So I'm definitely using this equation. And then from there, if I want mu, algebraically, mu is going to be F divided by R. So we've now just broken it down into two things. We need to figure out what the friction is, what the reaction is, divide them, that is mu, okay? So as I said before, I've got a couple of things. I've got the force diagram. Remember, we found out that K equals 556 over 13 in part A, and I've got the trigonometric ratios, okay? So if K equals 56 over 13, what I'm going to do is I'm going to replace that K with 56 over 13. So I'm going to write 56 over 13W, okay? Now, we need to resolve. And by the way, the reaction is at A. So I've called the reaction RA, so I should call this RA and RA as well, okay? So we need to figure out friction, we need to figure out reaction. Let's figure out friction first. Well, we need to resolve, don't we? So firstly, if I look at all of my forces, 1, 2, 3, 4, 5, 4 out of 5 of them are either vertical or horizontal. Only one that isn't is this reaction at C. So I need to put this into its components. So I'm going to do this. Vertical line like that, horizontal line like that. This angle here is always theta. So that being said, this right here, what would that be? This would be, this is adjacent. This would be 56 over 13 W, and then it would be adjacent cos theta, wouldn't it? Okay. And then this one right here, which is opposite the angle, is going to be 56 over 13 W sine theta, isn't it? Okay. So now if I was to resolve horizontally, then I can say that the frictional force going that way must be equal to any horizontal force going the other direction, which is just this one. Okay. So these two are equal. Okay. So I can say from there that F is equal to 56 over 13 W sine theta. Okay. Now from there, we got the triangles. We haven't figured out what sine theta is yet, which is easy though. Sine theta is opposite over hypotenuse. It's going to be 5 over 13. So therefore, I can plug that into there, and I can actually find an expression for F in terms of W. So W and then 5 over 13, like that. So now what I'm going to do, let's plug in 56 over 13. 56, hold on, let me do it. Let me do it here. Yeah, you should be able to see that. 56 over 13 times by 5 over 13. This is equal to, I know the bottom's 169, 280. Okay. So that means that I'm going to have 280 over 169 W is equal to my frictional force. Okay. So now I've got the numerator in mu equals F divided by RA. Now I need to figure out what the reaction is. Okay. Now again, it's just easy. We just got to, now, let me write this here. I don't think I wrote this here like an arrow just to indicate that we are resolving horizontally. So we've resolved horizontally. We've got that. Now let's resolve vertically. Again, just look at the vertical forces. Okay. I've got one here, RA, right? Which is obviously what we're looking for. Then I've got these two, don't I? Going down. And then I've got this as well going up. So there are 4 forces. 2 are going up, 2 are going down. The 2 going up are, I'll do it here, RA plus that 56 over 13 W cos theta. W cos theta. And this is going to equal, let me move this over here just so there's room. Move this here. And just write it implies. Okay. And that will equal the forces going down, which is going to be that 5W plus that W, isn't it? So from here, we could figure out what RA is in terms of W, because these are all W's. So I'm going to say I've got RA plus 56 over 13 W multiplied by cos theta, which we know is 12 over 13. This is going to equal 6W, okay? So now I can say that RA is going to equal, what's that? Let's do that, 56. All I do is change that to a 12, isn't it? Change that to a 12, is that correct? Yeah. 672, sorry, let me add plus, sorry. Plus 672 over 13, not over 13, over 169. 169W is equal to 6W. So therefore, RA is going to equal 6W minus 672 over 169W. So all that is now is just putting that into the calculator, obviously removing the W's. But we're pretty much done with that. So 6 minus 672. I know I could have written an answer, but I'm just going to write it out just for completeness for the video. That's going to equal 342 over 169. RA then is going to be 342 over 169W. Okay. So now we have everything we need. Remember, the question asks for the coefficient of friction. That is equal to F divided by RA. So what I'm going to do, should I do it on the next page or should I just do it? I'll do it on the side. So I'm going to bring this over there. And I'm going to bring this one, sorry, over there. So remember, I'll write out one more time. F is equal to F divided by RA. We now have both of these. So that's F is going to equal 280 over 169 W divided by RA, which is 342 over 169 W. Okay. So therefore, what can we do from here? I could say a couple of goodbyes. Goodbye, goodbye. And then I'm going to have 280 over 169 over 342 over 169. We're dividing by a fraction. I know I could put this in the calculator, but where's the fun in that? You know, last question of the paper. 280 over 169 times by the reciprocal. 342. Goodbye, goodbye. And then we've got 280 over 342. What's that? I don't know. I don't even know what it is divided by 2. 140, 150 plus 171. Oh, so it's 140 over 171. Hold on. 280 over 342. Got it. 140 over 171. So that's it. That's done. So therefore, mu, the coefficient of friction, is equal to 140 over 171. And that's it. That is done. And that is the entire paper finished. And that is the last question of the predicted papers. I'm about to go celebrate. See you later. Hey guys, so that's the paper. That's stats and mechanics done. So I'm hoping that you guys have found it helpful. Any questions that you found may be tricky, I'm hoping that this walkthrough has clarified things for you. But yeah, best of luck. You've got one more paper to do. As I said before, just keep doing papers. That's the best thing to do with only a couple of days left. And the good thing about stats and mechanics is it's not as broad as pure. You know, there's so many different topics that can come up in pure, but with stats and mechanics, there's always the 5 or 6 topics that are bound to come up, and they're going to be big chunks as well. So if you keep doing papers, then you should be fine. You could also do my predicted paper from last year as well. That's still a good paper to do, and all the other papers that are out there as well. But yeah, last paper of the year. I'm so happy. It's always a pleasure doing these papers. It's like my favorite part of the year, but it's so time consuming, and doing the predicted papers as well as the GCSE ones, it takes its toll. So I'm happy that this is the last one. I get to rest. But you guys are going to do amazingly well. The best of luck for paper 3, and yeah, good luck, man. Take care. Bye bye.